5, 4, 3, 2, 1. And we're live. This is Retraice, segment number 69 for Saturday, December 3rd, 2022 at 11 p.m. Eastern, 8 p.m. Pacific. Retraice is about what's going on out there. The short answer to that question is computer control. The long answer to that question, it's natural, artificial, and strategic intelligence. It's human beings. This is supposed to be on Do Not Disturb. Things always happen. It's not my fault. It is my fault. All right, listen. Today we're going to wrap up the page 48 journey and locate ourselves in the larger journey. Okay? We're talking about agent-oriented thinking today, but how did we get there? So, December, this is the December to Remember sales event, and we're only selling math and code. The December to Remember math and code event is better because we're not really selling math and code. Why? Because we're going to do a 6-month intense study of AIMA4e, Artificial Intelligence and Modern Approach by Russell and Norvig, 4th edition. And why are we doing that? Because the computer control game is player-oriented, and outsiders, which is what Retraice is for, Retraice is for outsiders. This thing is killing me. It's on Do Not Disturb. How many things do I have to mute? It's a computer control game. This thing, it's not my control. It's computer control. I have to hit the right things or it doesn't work. I lose control. I never have really control of it. Okay? The computer control game is player-oriented. Retraice is for outsiders, but we realize that outsiders are not players. So we're learning to play. What does that mean? It kind of means learning AI, like the technical stuff, the realness. All right? And the starting point for that is AIMA4e, a modern approach, artificial intelligence modern approach. We're going to do maybe 6 months on that, starting in January to June inclusive, but we're going to get serious into the math in December as we've been doing, and that's why we're dwelling on AIMA4e page 48, because that's where it all starts, the math and the code. Those are the two things that are going to trip us up. It's not the English in the book that's going to trip us up, it's the math and the code that's going to trip us up. That and notifications on our phones, those are the things we're going to focus on in December. Math, code, and notification settings. I never had a problem with it until I did. All right. We've talked pseudocode. We've talked Python. We've talked math. We've talked about putting them all together. We've talked about how you get from the pseudocode to the math, or the pseudocode to the Python. We've talked about how we can do the math with the Python. What's the last step in our cycle? We have a cycle. Okay, so first of all, we have to be disciplined this month. We have to be disciplined for the next 7 months. We have to be disciplined for the rest of our lives because the deadline problem, we don't know how much time we have. Okay. So all these little side tracks that I love, I love the side tracks. I love them. They're dear to my heart. I think they're part of who I think I'm on one right now. Cut it off. Okay. We have to stay on track. That's discipline. That means the way I'm thinking of no diving off the boat. Okay. You're on a boat ride and you see something cool in the water. You're off the coast of Australia. You're at the coral reef. Oh, dive in? No, stay on the boat. You have to finish the boat ride. If you dive off every time you see something cool, you're never going to finish the boat ride. It's going to end up like Gilligan's Island. In our case, what that means, there's this thing, agent-oriented software engineering. Oh, it's so fascinating. I love it. I've loved it since my book's on the floor, so I'm looking down at it longingly. They mention it in AIMA4e, like a few pages after 48, and then at the end of the book. And it's like, the most awe-inspiring, explosive stuff is little slices at the beginning and the end of the book. Anyway, I got to get back on the boat. I'm diving off. I got to get back. I'm all wet. All right. But I want to talk about that. And that's kind of what today's segment is about, but not much. Really what we need to do is round it out and develop a system for doing what we did on page 48 for every other page that has math or code or both throughout the book. We've already talked about the mathematical appendices, the mathematical appendix, the code appendix. Those are actually the same thing, right? Were they the same appendix? Yeah. And then the other one was, I forget. But anyway, we already talked about the code or the math that they want us to focus on. But there's math throughout the book and there's calculus in there and they don't talk about calculus at the end, blah, blah, blah. Okay. Here's our system. It's based on what we've already done. We start in English. We yap, 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 chat, chat, chat. Okay, fine. Anybody can do that. It's a native tongue. It's easy. This is what we're born to do. This is how we've evolved. We're meant to be yapping. All right, I am anyway. I don't know about you. All right. So we start in English. We don't worry about comprehending English. We worry about comprehending code and mathematics. That's why we front load them, and that's what we're doing. So what do we do when we're in English? Get out. You got to get out. You got to get out of out of English and into math and code, into formal language. Pick your, it could be math or code, but let's say code comes first. So first, we comprehend things in yap, yap, yap English, and then we sort of, there's a transition stage to pseudocode English. So what are we talking about here? Let's have a look. I'm going to switch you to where we can have a look, and I'm also going to join you in this having a look. So here are our notes. This is Retraice notes. If you go to the Retraice, like this is what it looks like. You need to see this because it's so awesome. It redirects you to our libsyn feed here, and these are where you can get all Retraice notes, and there's a bajillion of them. Look at this. Look at how much you can get, okay? And then for our series right now, Re69 was the first one on page AIMA4e, page 48. Here's where we first introduced the pseudocode, okay? And then the AIMA guys implementation, or the AIMA implementation project. This is their implementation in Python. Okay, we talked about that. And then in Re66, we talked about other things, but then we did a lot of our own code in IPython down here. So this is the same stuff we just saw. And then we did the long way over here on the left. And then we did the shorter way on the right. And then finally the super short way here. Okay, so we got out of English. We got into, via pseudocode, we got into Python. And then, what's this? What's this big scary thing? What's this big upsetting scribble? Okay, it's not as upsetting as it seems. It's just really the hard part. Can you see that? That's, I don't know if I said this. That's a Greek sigma. That's the Greek letter capital S. Okay, it doesn't look like it. The lowercase s, Greek lower sigma looks like that little thing with like a little circle with a little gun on the top of it, or a hat, or whatever. And then at the end of it, this is a final sigma, but that's the capital Greek S. Okay, that's what we're dealing with. Anytime in math, you're often, the first letters you deal with that you don't recognize are Greeks, and then they go on from there and they do all kinds of fancy scripts and stuff. Anyway, we talked about how this just represents a sum of the number of, in our case, in the number of entries in our table that we would need given bar P number of percepts. In our case, it was just red and green, and then up from T to lowercase t to capital T is the number of percept moments in the agent's life. And so this is just how you write down a short version of the long version of that arithmetic that looks like this. Up here is the algebra, and down here is our specific situation where we have two percepts, red and green. We take 4 steps, and then the end of the life is 4, or T. In the previous videos, these weren't red. They should have been red. Everything T should have been red. I fixed it in the notes, both for Re66, actually Re67 here, and then also Re68, because that was the good color coding scheme, but I made a mistake and I didn't make the 4 and the T red here. Okay, we got out of code and into math. Why did we do that? We'll talk about that in a second. And then finally, this is just sort of like the whole thing, maybe abbreviated, the math and the code. This is from yesterday's notes, Re68, okay? You got the basic equation that gives us the number of table entries, then you got it expanded so that we're not using scary sigma notation, and then we've got the actual arithmetic where there's no algebra, and then we've got our code. This is the short for loop version of how to count the number of, or to discover or calculate the number of entries that we would need in our table. And then these are the 2 key inputs. The number of percepts, in our case it was 2, and then the lifetime of the agent, in the case of our thing it was 4. Okay, so that's, what did we do there? This is what we did. We did ECMP, English, code, math, and programming? No, progress. What do I mean by that? You start in English, it's easy. Via pseudocode, we transition to code, software like Python, a programming language. What are we doing in code? Well, we're making a machine. We're using the universal architecture of von Neumann computers, universal Turing machines, in order to make and remake many different kinds of machines without having to move any hardware, only moving electrons and changing voltages. That's, we're building and rebuilding and building again different machines. We don't think of them as machines because we don't see metal, we don't see plastic, we don't see gears, but it is, it is a machine that can be any other computing machine. Okay, that's what your computer is. That's what all computers are. So we moved out of English into the code and we started making machines to do what? What do machines do? They do work. We have work that needs to be done. I don't want to figure out, I don't want to do the number of, I mean, come on, look at this. Like if we were to manually figure out how many entries are in the table, that's this, okay? That's this thing. Okay, for the first action, what if we see red? Oh, okay, let's do an action for that. Okay, what if we see green? Oh, let's do an action for that. Okay, so that's the first moment of his life, but let's say he has 2 moments. Oh, okay, what if it's red, red? What if it's red, green? What if it's green, red? And then by the end of it, we will have this combinatorial, this wasn't a combinatorial explosion, this was just a combinatorial little flame out at 30, okay? We ended up, we have to cover every single combination of percept events in a very simple world, and we still have to go all the way to 30. Forget about it. If you've got to do, like your last, you've got T is 14, your last entry is going to be more than 16,000, it's going to add 16,000 entries to the table. If you have 3 percepts like red, green, blue, your last entry at a 14-year lifespan is going to add almost 5 million entries to the thing. We're not doing that, okay? We need a machine. That's the computing stage. ECMP, we're at E. C is for computing. Make some machines that do some work. What then? Okay, done. Great. Excellent. What if the machine says that the table was supposed to be 32 entries long? What about that? What if the machine is wrong? Or just, what if we really need this machine to be good? It needs to help us get product to market, which sounds so boring, win a war. This has happened many times, especially in the last 200 years. The machines have to perform, have to succeed, or we lose the war. What is losing a war like? You don't know. You don't know. Well, I'm sure some of you might know, but most of you don't. It involves death, okay? Death and lots of bad things in addition to that. What if our machine is wrong? Math. So we're at E for English, C for computing or code, M for math. Why do we go to the math? The math can help us check the performance of the machine. If it comes up with something that is literally mathematically impossible, we know math. We can do the math based on reasoning from obvious and undisputed premises and linking conclusions. That's what mathematical proof is. It's just start with the most obvious and agreeable thing, work your way through totally non-controversial, everybody agrees steps, that's mathematical proof, and then arrive at your conclusion, which might be surprising compared to where you started, but everybody agrees on the steps, so everybody agrees on the conclusion. You use math so that you can first find out whether you should trust a machine, and second, just as importantly, you need to know what that machine can do. Okay? Combine math and physics and you know, if I shoot the cannonball that way, at this angle, with this much powdery explosive, and it weighs this much, I know for sure it's not going to land on Jupiter. Why? It's not that it's physically impossible for it to land on Jupiter, but if you launch it from Earth, it's impossible. Okay? You have to think that way. There's no computer there's no computer program that you're going to write that's going to help you with that if you don't have the outside knowledge bearing on the situation. You need to know the limits of your machine and the limits of your environment. Not the limits of your environment doesn't have limits. It is the limits. It doesn't have them. It is the limits. Okay? So we transition from making our machine, playing with our machine, seems to work, kind of starting to build confidence in it. Well, what are we checking? What was I doing yesterday? Like, I'm doing this thing, clicky, clicky, clicky. I didn't want to do this. I don't want to copy 10, 15 digits using my eyes, crappy, fingers, crappy. I don't want to do that. This thing, surprisingly good, this thing. I don't know what 90% of this stuff does, although I'm learning over time. But man, the battery life is excellent. What was I talking about? Yeah, what was I doing? I was checking it. I was checking the machine. I was like, it came up with 4 million, whatever. Type it. Now, this thing is another machine, but you use 2 machines to check each other. You increase your confidence. And if you can do the arithmetic in a situation like our 30 entry table, I don't need a calculator to do that one. I can do it in my head. I know it based on, so the math is telling me what's possible and what are the limits of the machine. What then? We've talked to yappa. We type, scribble. I don't know what the math one is. Okay, we've done English, code, math. What's the last thing? ECMP, progress. We've done all this work. Go do something worth doing. That is where agent-oriented software engineering comes into play. But I'm not going to talk about it because I am staying on the boat. What I mean, though, by the progress, so Alfred North Whitehead, the mathematician, great guy, great thinker, he worked with Bertrand Russell on Principia Mathematica. He said at one point something, I'll dig up the quote, I don't know where it is, but he said something like, civilization advances in proportion to the things that we can do, the number of things that we can do without thinking about them, or the number of steps we can take without thinking about them, something like that. I think I nailed that, didn't I? I just that came right off the tongue perfectly. So we make progress in civilization, according to Whitehead, and you don't have to agree with this, but it's one way of thinking about it, by automating things, more or less. He was talking about, this was in his math one. I mean, he did a lot of math, but his Introduction to Mathematics, he was talking about, I think he was talking about, when he said that, he was talking about notation and how powerful a good mathematical notation is. It basically reduces, it takes all of the brain work out and makes it just a matter of vision, just makes it, things need to be where they are and they need to be the shape that they need to be. And then your notation is doing all the work back and forth with your visual system. I think that's when he said that. When he said we advance based on how many things we can do without thinking about them. That's ECMP, progress. So what does that mean in the case of our table-driven agent? Well, look, I didn't implement any sort of agent-oriented software to do something I really need done around the house. And I don't mean literally around the house. I mean, even in my software world, in the world of code that runs Retraice, there's a lot of things that I could be doing to improve that code. There are a lot of little things, but none of them have risen above the line, so to speak. But could I use the table-driven agent architecture, the agent program that takes the agent function, a table, could I use that to do things to improve my code? Absolutely. Absolutely. I mean, we're talking a very simple number of percepts. The problem is, and you can also design the table-driven agent so that it doesn't need the complete table. That you can just say, if in your agent function you can say, if your percept history is this, do this. If it's this, do this. If it's anything else, this is an if-then-else loop. If it's anything else, just do nothing. Go get another percept. I'm only interested in these two percept histories. If you see one, then do this. Okay, then you execute some substructure, some what do they call it? There's a name for that. Anyway, Althoff, I'll put it in the notes. Okay, could we do that with table-driven agent? Absolutely. Are we going to? No, we have to stay on the boat. We have to prioritize. But we need to be thinking about what we could do with each agent architecture and each tool that we discover in AIMA4e we need to think about it in terms of usefulness and implementation in the real world. Progress. How does it help us make progress? That's the last step. ECMP, English, code, math, progress. All of them are squishy. You can move them around a lot. You can rearrange them, but now ECMP also happens to be an acronym for something in packet switching and the internet architecture. Equal cost multipath routing, equal cost multipath. I like that because there's something distantly related to what we're trying to do there. But anyway, that's not the ECMP I'm talking about. Agent-oriented software engineering, Shohan, 1993. Go check that out. I'll put it in the notes. Autonomic computing, check it out. I'll go put it in the notes. I'm not going to talk about it right now. Another way of thinking about the progress thing is you've got a hammer, go find some nails. The agent or the table-driven agent is a hammer. It's the most simple hammer. It's a dinky, poorly designed. The balance is all. It's just not useful for very many things, but it's not useful for zero things. You've got a hammer, go find some nails. That said, don't see everything as a nail now that you've got your puny little hammer. The last thought I'll leave you with is one that came up in Retraice 49. And that was about China. What does a mobilization look like? A mobilization for war? The way that I think about it, about artificial intelligence, one of the ways I think about it is there's sort of a difference in attitude and mentality between job AI and other kinds of AI. There's hobby AI, where you just like doing it and it's cool. And I'm sure there are other kinds, but the other one that I think of, And job AI can mean I'm trying to get a job by learning this AI. It could also mean I'm trying to start a business by developing something on the basis of AI technology. That's all commerce. That's all well and good. That's what we want. We don't want people to be in the other mode of AI that comes most clearly to mind for me, which is war AI. But when I asked the question at Re69, and what I'm asking now in the same mode, is what does a general mobilization for war in 2022 or 2025 or 2030 or 2040, what does it look like? Is it tanks rolling off the assembly line? Is it a scramble for global resources, fuel, or combustible materials? Is it a rationing of food? It's going to have some of all that. And we're seeing some ghost of the future, of wars in the future, in the war in Ukraine. There's a very hybrid feel to it. It seems like an old style Cold War NATO versus the East sort of. It's like stump grinding. It's just ugly. What we're not seeing, because it's just harder to look at, is the fantastically important role played by the Bayraktar. Is that the really cheap Turkish drone that they're using it with such success? We're not seeing the cyber back and forth. One of the things that people anticipated with Russia's attack on Ukraine was that they were going to immediately turn the lights off. Russia was going to immediately demonstrate just how badass they were at hacking. Didn't happen, but lots has happened, and we're outsiders. We have no way of knowing the details of that stuff. We have to accept what people tell us or not. But you can be sure already today and more and more and more into the future, while you're doing your job AI, as we all would prefer to be doing all the time, when war comes up, and it will come up again and again and again, that war AI is what general mobilization is going to look like. And I'm not sure we even know how to picture that. The people who are doing it know. The insiders to those particular domains, the relevant domains. But man, I don't know if you know anything about hacking, cybersecurity. It's a different world. It's InfoSec. It's a different world. And I'll leave it at that. So we're going to stay on the boat. We're going to stick to math and code in December. We're going to follow the ECMP, English Code, Math, and Progress cycle as we encounter new things. And every time we get a new tool in our toolkit, we're going to look for ways to use it. And we're going to keep in mind what progress really means. Sound good? Good. All the references will be in the PDF notes on the website, retraice.com, retraice.com. This is Retraice segment number 69. Same time tomorrow, 11 p.m. Eastern, 8 p.m. Pacific. Go Blue. Signing off.